So there are two types of infinite limits. Type 1 is where x is approaching infinity or negative infinity, and type 2 is when the function itself is approaching infinity or negative infinity, so like the limit. So here we're going to look at this example where the function is 1 over x minus 3. So we have the graph of what that looks like. So we're going to use the graph to kind of help us figure this out. So the first type is where x is approaching infinity. So remember we talked about horizontal and vertical asymptotes. So whenever x is approaching infinity or negative infinity, that's really dealing with the horizontal asymptotes. So if I look at the function that they're given, okay, the rule for the horizontal asymptote, well, the top degree is 0 because it's not there. The bottom degree is 1. So since the bottom is bigger, we know that this has a horizontal asymptote at y equals 0. Okay, so the limit as x approaches infinity and negative infinity should be 0. And we can look at the graph and see what this is about, right? So here, as x approaches infinity, so as the graph is going more and more to the right, you can see that the y values are getting closer and closer and closer to 0, right? They're approaching that horizontal asymptote. So here we have 0. The limit as x approaches negative infinity of this function, again, as you go closer and closer and closer to negative infinity, as we're going more and more and more left, the y values are getting closer and closer to 0. Okay, so the little trick is look at the horizontal asymptote so you can see it from the graph and you can also get it from the function itself. Now type 2 is when the limit is actually going to approach infinity or negative infinity. So x is approaching the vertical asymptote. So here, the vertical asymptote we can see from the function is when we set the denominator equal to 0. So if I set x minus 3 equal to 0, I get x equals 3. So x equals 3 is my vertical asymptote. That is what the x values are approaching. So if we look at our graph, right, as x approaches 3 from the right, so here's the right-hand side, as we approach 3, our graph is going up, 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 right? So it's approaching positive infinity. So it's going up. As x approaches 3 from the left, so here we come from the left side and we're approaching 3, it's going farther down. So that's approaching negative infinity. Remember that the limit has to be the same value from the left and the right in order for it to exist. Since the limit on the right is positive and the limit from the left is negative, the overall limit as x approaches 3 does not exist. So we're just going to look again at the two types of infinite limits. So the first type we said was when we're dealing with the horizontal asymptote. And that's when we're dealing with like the top degree and the bottom degree, if it's a fraction, and we're always going with the highest degree. So here, I have all this other information here. I have a 4x to the 5th. That's my starting, that's my leading term, right? Everything else that comes after it, like, yes, it's important when we're graphing things, but in terms of finding the limit, the rest of it doesn't really matter. We're only dealing with the front. So if we compare the two graphs, this graph in blue is the actual function, okay? This graph in red is just the leading term. And you can see they have the same behavior. So even though they're not the same graph, as x is approaching infinity on both graphs, the y value is approaching infinity. All right, it's going up as it approaches infinity. Okay, same idea with this one. So here we have a lot of things going on. We only really want to deal with the first term on the top and the bottom, right? Everything else, again, important. However, for limits, not really. So when we look at that, we say, okay, the degrees, the top degree is bigger than the bottom degree. So that's going to be the horizontal asymptote would be there is none, right? When there is no horizontal asymptote, it's either going to be infinity or negative infinity. So as it approaches infinity, we can see both the purple and the green, right? They are doing the same thing. They're getting closer and closer to infinity. They're going higher and higher up. So the leading terms are the things we need to look at. Even though there's other information in the function, we only really need to focus on the leading terms. The second type of infinite limit, that is when x is approaching the vertical asymptote. Now these are a little bit, I guess, more annoying, I would say. If you have a graph, like we did in the previous slide, I'll go here. So if we had a graph, it's easy enough to look at, right? As approaching 3 from the right, 3 from the left. Okay, we can see that. When you don't have a graph, right, and you're needing to use just the function, you want to make sure that you're trying values on each side of the value it's going to. So I'm just going to make a little note here, right? So we have to try both from the left and the right. So what I mean by that is I'm going to break this up into two different limits. So first I'm going to look at the limit as x approaches 3 from the right. Okay, it doesn't matter if you do the right first or the left first. All right, I can't solve this with direct substitution. If I plug 3 in, I get 0, right? So from here, so I can't do that. So when I split it up, I'm going to pick values that are close to 3, but coming from the right-hand side. So for instance, if I pick, let's say 4, right? If I plug 4 in, I get 2 times 4, so I get 8 over 1, so I get 8. If I pick a number like 3.5, I'm going to get 2 times 3.5, so I'm going to get 7 over 0.5, which is 14. So the number went from 8 to 14. So the number is getting bigger. So the closer I get to 3, the number is going to keep getting larger, and it's going to approach infinity. So you could pick like 3.00001 and plug that in, and you'll see that the number is even larger. I like to just kind of test out a number that's like a little farther away and then one that's a little bit closer. So then I have to check the other limit. So the limit as x approaches 3 from the left of 2x over x minus 3. Okay, so I'm going to do the same thing, but I'm going to pick numbers that are close to 3 coming from the left-hand side. So for instance, I might pick 2. If I pick 2, I get 4 over negative 1. So I get, 4 over, sorry. If I pick 2, I get 4 over negative 1. So I get negative 4. If I pick a number that's closer to 3, like 2.5, I get 2 times 2.5, which is 5. And then I get 2.5 minus 3, which is negative 0.5. So I have negative 10. So my values are getting more negative. I went from negative 4 to negative 10. Okay, so I have negative infinity. So now the limit from the right and the left, they don't match. So the overall limit, I'm just going to draw a little thing here, that is actually going to be does not exist, right? Because the left and the right limits don't match. So we always want to pick numbers that are close to the value, but coming from the sides. Okay, so in this one, I'm going to do the same thing. I'm just going to pick values that are close. So we're going to break it up into the limit as x approaches negative 4, and I'm going to do it from the right of x squared plus 2x plus 1 over x plus 4. So I'm going to pick two values. I'm going to negative 4 from the right, so I might pick negative 3 and negative 3.5. And I want to plug them in, and I want to see, are my numbers getting bigger or are they getting smaller? Okay, so in this case, they get bigger. I'm going to check the other side, so the limit as x approaches negative 4 from the left. So here I'll pick two values that are less than negative 4 because I'm coming from the left. So I might pick negative 5 and negative 4.5, and I'm going to see what's happening with those. And in that case, the numbers are getting smaller. They're getting more negative, so that becomes negative infinity. So again, overall, the limit as x approaches negative 4 is going to be does not exist because the left-hand limit and the right-hand limit do not match.